excited about our next speaker. You may have noticed a pattern here. I'm really excited about all the speakers. but hey, that's because we're a small committee and we get to pick the speakers we want to have, so we're really excited. And I'm really excited about this next speaker because I've known Luke Francel for a long time. And he is one of those people who has done a lot of stuff for the software community in the Twin Cities. Raise your hand if you've ever been to a Mini-Star event, Mini-Bar, Mini-Demo, any of these. Yeah, you have Luke to thank for being one of the founding members who got that stuff going. So it's with great regret that I inform you that Luke does not currently live in Minnesota, but perhaps having come back and spoken in Minnesota again, he may change his mind on that at some point. But anyway, and I want to tell you one other thing about Luke's company, which is my company, Drama Fever, is a customer. And if your company's website search sucks, you might want to look into theirs because they can actually make your site search not terrible. So that's my plug. It's like I'm a very happy customer of his company. So I'm very excited for Luke to tell us about the stuff that they're doing to help developers do their monitoring. Give it up for Luke.
Cool. Thanks, Bridget, for that great introduction. Drama Fever is not only a customer of my company, but they're our first paying customer, so that's pretty cool. Before I get started, I want to take a minute to thank the organizers of this conference. As Bridget mentioned, I have helped organize conferences before, and I know it is a ton of work. So I really appreciate all the work that the organizers and the volunteers put into making events like this awesome. And I'd also like to thank the sponsors because, again, I know that it's very expensive to run a conference, especially at a big hotel venue like this. And so they really make it possible. And finally, I'd like to thank my company because they paid for my flight out here. And so I think I'm contractually obligated to say that we are hiring. And we know that Minnesota developers and ops people are awesome because we've hired several of them. Unfortunately, they all live in San Francisco now, but that's a cool town too. All right. So I'm going to talk about helping developers monitor their own application. And I am a developer. So SwiftType, as Bridget mentioned, is a search as a service company. We help you add search to your application using an API, or you can use our web crawler. But we're a pretty small company, and so as a developer there, I do a lot of things. I do a lot of programming, obviously, but I've also done a lot of documentation, trying to make our API easier for people to understand. And I've also done a lot of customer support. This has actually been pretty cool for me, I think, because speaking of empathy, there's no better way to empathize with your customers than actually answering their questions about why they can't figure out how come your software sucks. But finally, I am the world champion in our company of posting funny cat pictures in HipChat. I love cats, and I have 2 per programmer stickers if you want one. Only 2, so be quick. But one thing I don't know very much about is operations. I have been, the Unix person at companies before, and I know my way around the command line. But this is usually because of my extensive experience in the early 2000s, reconfiguring Apache over and over again to get mod PHP pointed at the right MySQL headers. I also have extensive experience recompiling Slackware over and over again to get my Sound Blaster driver working. But again, that was a long time ago. And so I guess my point is that you probably don't want me running your servers. I can kind of find my way around, but definitely you do not want me running your servers. So you might be wondering, what is this guy doing at a DevOps conference? And trust me, I'm wondering that too right now. But I accepted the invitation to speak here, and well, they accepted my invitation to speak here, I guess. And so I knew I had to do some research on what DevOps is all about. So here's what I found out. First of all, I found out that empathy is a core value of DevOps. Big on the hugs, big on tearing down silos, breaking down walls. And I also found out that you really can't talk much about DevOps without mentioning John Allspaw. And according to Wikipedia, he is notable only for helping invent the game Faceball while working at Flickr. But you know, I'm a professional, so sometimes I know that you need to dig deeper than Wikipedia. And so I did a little more research about him, and I found out he's involved in a company that somehow uses monitoring to sell crafts. I'm not really sure how that works, but I get this from the most reputable sources. And there's also some terms that DevOps people use that I found out about. They're really big on Dockers. I mean, Dockers are great pants, but they just don't seem effective for every situation to me. Another term I found thrown out around a lot was chef and puppet. And the only chef puppet I could find was the Swedish Chef. I don't know how this guy helps you with your infrastructure, but apparently he can do that. Another thing that gets thrown around a lot is postmortems. Again, I'm not really sure how dissection helps make your infrastructure work better, but apparently it does. But the most important thing I found out about DevOps is that you cannot talk about DevOps without spending a long time talking about what you think DevOps means. So, every podcast, every blog post, every talk, you've got to spend at least 20 minutes talking about what DevOps is. I was going to talk about monitoring, but I think I now have enough time to maybe squeeze that in at the end after I talk about DevOps for the next 20 minutes. Seriously though, I am a little confused. What's with all the hugs and the empathy? When I was coming up as a developer, sysadmins were mean. They were all about the bastard operator from hell and smiting users with their LART. But now it's all about hugs and empathy, and I guess that's cool because now I don't have to be afraid of my sysadmin anymore. So as you can see, not only do I not know that much about operations, I don't really know that much about DevOps. And so my journey to speak here today started with a conversation I had with Bridget when she was out in the Bay Area for a conference, and a DevOps conference. And she asked me why I hadn't attended. My startup's cool with it. We do DevOps. We've got Chef. Code is infrastructure. Why didn't I go? And she asked me, do you think DevOps is just for ops? And I had to admit, I kind of did. Obviously developers are part of DevOps because it's right there in the name. But when I would read about it, the people who are most excited about it were usually ops people. And her question really got me thinking about how devs and ops work together and how devs and ops work together at my company. And so I wanted to tell a story about a problem that we solved together, and maybe you can take a lesson from that. But what I'm not trying to say is we do DevOps right, or we have all the answers. I don't even know if doing DevOps right is really a thing. This is just a story about something that worked for us. So the issue that we were running into is that we have an API for indexing content. This is how you add content to your search engine, or one of the ways anyway. And it works the way that most web apps work. You get an API request coming in. It goes into a queue for processing. And then when there's an instance of our application available to process it, it'll grab that. It'll run some database queries to make sure things are valid, and then it'll store it in MongoDB. I'll be giving another talk later tonight at the bar about why I don't recommend using MongoDB. But for the purposes of this talk, let me just say, until extremely recently, MongoDB has had a global read-write lock on the database. And so what would happen to us is that we would sometimes have traffic spikes, and the traffic would start coming in, and our application, our application is not slow. It's actually pretty performant, but a lot of the time it would be spending would be waiting for queries to come back because something was locked writing, or it wouldn't be able to save the record because something else was going on in the database. And so what would happen is in this traffic spike, this queue of requests would start filling up. And then when it was full, we're in a bad place because we're going to start rejecting requests because there's no way that we can process it. So this is bad because we're a multi-tenant application. So that meant that like one customer could cause bad experience for all the other customers. So the first thing that our ops team did to help deal with this problem was something that I think is actually pretty cool. They put another layer on top, which is a front-end router. And what this can do is it looks at the request and it can determine which customer it's for based on which search engine you're looking at, things like that. And so in this case, like if customer A is sending us a ton of traffic, their requests get routed to their own queue, their own instances of the application. And if they're causing a lot of backup, like they're going to be the first ones affected. The customer A will see the 502 errors. Customer B hopefully won't. But there's still a problem, which is that the MongoDB, where we're saving all this data, still has this global write lock. And read lock. So the problem is that customer A can still affect customer B. And so that's not good. And there's a couple of ways we could deal with this. We could shard MongoDB. We could move off of MongoDB entirely. These things seemed too hard. So we decided to come up with another solution that would let us not rewrite our whole software stack so that we don't use MongoDB, but get MongoDB out of this request. And what we did is we implemented an asynchronous API. So the way that this works is that inside our application, we'll take the raw JSON from the request. We'll do some really basic input validation. So this is just looking to make sure all the keys are in the right place, that it's got an ID, stuff like that. It's not doing any database queries on MongoDB. Then once we ensure that the input is at least structurally valid, we'll create what we call a journal. And we use this pattern in a few different places. And what it lets us do is record that something that we're going to do asynchronously has happened. Like we could just enqueue the raw JSON right after we receive it, but then if we drop that job, that background job, we would never know that it even happened. So these journals let us know that the input occurred, and then this will let us figure out if it stopped working. So in this case, this will be called the document creation journal, and then we enqueue the ID of the document creation journal, and a background worker will process that later. And the background worker is the one that handles writing to MongoDB. And of course, since it's in the background, now we don't really care so much that it's causing the database to back up. And we can, if things are overloaded, we can like scale it back, things like that. So we have removed MongoDB from this request, and now our API is fast again, and so we're declaring success. But now we have a new problem, which is how do we make sure that this keeps working? And the answer is, of course, monitoring. Now the problem with that is, as a developer, I don't really know a whole lot about monitoring. Like, I know that it exists, right? And I know that we can use Nagios to write checks and alert different people depending on how this is working. But if you ask me to set that up from scratch, it would take me forever. Like, I'm not an expert at that. And this has been borne out in like previous jobs and companies that I myself have started. Like, the way that I would find out that things weren't working was by them not working and people complaining. And that's just not a good place to be. So fortunately, we have an ops team at SwiftType that helps with these sort of things, and they built a pretty cool framework for developing monitoring checks. So by writing just a little bit of Ruby code, we can quickly deploy new Nagios checks and find out when things are broken. And so I'm going to talk a little bit about how that works. So the way that you use this is you create a subclass of this SwiftType monitoring check class. This pulls in some code from Sensu. I don't think we actually use Sensu, but we're using their plugin API to make this possible. So this gives you methods OK, critical, and warning that you can call to indicate the response status that should be alerted in Nagios. And then it's got some helpers for defining thresholds. So there's a warning threshold and a critical threshold. And then as a developer, all you need to do to work with this is implement the run method. And so here's an example of how that works. So this is a hypothetical monitoring check. You can see that the first two lines there are defining the thresholds. And then in the run method, the first thing we do is get some metric. So this could be doing acquired by doing a query in MySQL. It could be looking up a value in Redis. It could be checking a value in statsd. Anything you can do to get yourself a number, you can use this framework with. And so once you have whatever number you're trying to check, you can just compare it against the config values that were defined by those warning option and critical option values. And so here, if it's above the critical warning, then we return with this critical alert. And if it's a warning, we do a warning. And if it's OK, then it would just say, all right, it's good. So here's the code for doing monitoring on the document creation journal table. So the thing that we're trying to avoid is that, say, the background worker stops working. If that happened, that means that the journal entries would get too old. And so what we do is grab a MySQL connection and then run a query. And this query looks at the oldest record in the document creation journals table and gives you the number of seconds ago that it was created. And so I've commented out the actual checks, but you can imagine it's just an if statement like we saw in the previous slide. And I was able to write this pretty quickly because we use this journal pattern in a few other places and had monitoring checks for them already. And so what I did is I just copied and pasted it and modified it to point at the right table. And so we were able to get this out pretty quickly, and it was actually pretty cool. But shortly thereafter, we needed to add another monitoring check for another journal table. And being a programmer, I hate repeating myself. So I extracted that code into a helper method. And what this does is you just give it the name of the table and then any ID columns that it has. So it could be like ID, or it could have a compound primary key. And then the timestamp column that you want to look at. And then it generates that SQL query that we saw in the previous slide, and then returns to you an object that indicates how many seconds old that record is. And then you can use that object to print out different things in your alerting. So with this refactored code, I'm able to rewrite the previous check like this. And you can see that the main body of the code is just this lag info check on the third line there. And now that takes away a lot of the boilerplate for this, and I can actually fit like the whole method on this slide. So with this framework, I was really easily able to write a monitoring check for this document journal problem, and then other journal issues that we came up with. And it turns out that monitoring is pretty addictive. Once I'd written one check, I saw the potential of it and wrote a bunch more. So I've written queue size checks. I've written another check to make sure our cron subsystem keeps working, because it's stopped working and we didn't notice for like a day. And I think the interesting thing about this is that developers are subject matter experts in their application in a way that the ops team might not be. We know how the application is supposed to work. We can code. And so if we have the tools, it's pretty easy for us to add this monitoring and to really help the ops team understand what issues are going on in the application. And it's not just Nagios checks. It's also about making it really easy to add stats D keys with the right namespace and things like that. And those are things that the ops team at my company has helped with, just to make sure that developers are logging and monitoring things in the right way that makes it easy for everyone to use. So if you want to check out this code, I literally just open sourced it like right before I came down here, and you can check it out on our GitHub repository. It's a little rough because I pulled it out of our existing code base, but you should be able to look at it and at least get some ideas for like how you could implement this at your company. So getting back to the idea of DevOps, I thought that this was a really cool example of something that we saw Donnie talk about this morning. And I actually saw him talk about this at Minibar this year. So I think it's a cool example of breaking down this wall between developers and operations. In Donnie's example, in the classic IT way of doing business, developers are responsible for their development environment. They're responsible for coding the application and setting up, MySQL, whatever they need to do on their laptop. Like they kind of own their laptop. And then when they're done with code, they ship it over the wall, and it's ops problem now, right? Like ops runs the production servers, they run the application, and they run the infrastructure. And so I think one of the benefits of DevOps to developers that's come about is that in this model, it's really hard to get operations to set up some new tool that you need, and that's really shifted, I think. So what Donnie talked about is rotating this wall. So instead of having a wall between developers and operations, development and production, you've got a wall between infrastructure and application. And so the developers are responsible for the application, both in development and production, whereas the operations are responsible for the infrastructure. So I don't think that at my company we're really here yet. I mean, we're not using VMs or Docker containers to develop our app. I still have a full copy of our app on my computer here. But this idea of the monitoring framework, I think, is really congruent with this idea of infrastructure, of ops providing infrastructure. The ops team has built out all the necessary tools that we need to monitor our application, and they've also helped us make it easy to write monitoring checks. So by doing that, they're providing the infrastructure for the developers to help monitor their own application and helping us as teams be successful together. So I'll just close with this thought, which is probably not original since DevOps needs developers. Developers write in the name, right? I think that's pretty obvious. But I think my point here is that a lot of developers don't really see DevOps as super relevant to them. They're happy to keep doing things the way they were doing, because honestly, it was pretty awesome, right? I mean, it's like I write the code, I give it to you, now it's your problem. Like, as a developer, that's kind of nice. But I think we need to move past that. And for DevOps to be successful in an organization, I think you need developer buy-in. And it can't just be about ops. So how do you get that buy-in? And I think this idea of providing infrastructure for developers is a really powerful one if you're trying to convince developers at your organization that DevOps is important to them too. Because developers like things to be easy. We're kind of lazy. And if you make it easy for them, they will understand the value. I can read 100 talks from Etsy about why monitoring is important, but until I saw how easy it was to write my own check and just get that out into production super quickly, I didn't really like internalize that value. So I think if you're trying to roll this out, focus on providing that infrastructure for your developers, and and show them the true value of the cooperation between ops and developers. Cool. Thank you.
Thank you, Luke. That was amazing. It's very exciting to have a talk from a developer on exactly this topic. And we have time for a few questions. And again, Luke had a lot of stuff up here, so I'm sure people are going to have some questions about it. We'll start over here. Yes.
With respect to devs writing monitoring, do you think that has a higher return on time invested than like unit tests?
So the question is like, do devs writing monitoring have a higher return on investment than unit tests? That's a good question. I think that they're kind of orthogonal. I mean, so the code that I'm talking about in this example, this talk, this document background journal stuff, that's all unit tested and system tested even. But that's not going to save you if the background worker crashes. I mean, for example, the cron thing that I mentioned, our cron job stopped working because they were starting the wrong version of Ruby. That's not something that we're going to notice in our development environment. And so we got alerted to that because of this monitoring system I'm talking about, because it backed up. And so that's how we found out the problem.
My question was around testing. When you put in the dev test, are you putting it in the dev side, the ops side, or just somewhere else?
So the question is, where does testing fall? That's a good question. I think it's obviously important for developers, but I think our ops team has actually done some really interesting thing about testing. I didn't have time or really a way to fit this in, but our ops team has also written a framework, going back to this theme of providing infrastructure, they've written a framework for testing our Nginx configs. So like I was saying in the talk, like the last time I configured a web server, it was Apache, and like I know that's like totally passé now. So we use Nginx, obviously, but I never really used it before, like not directly. But thanks to this testing framework they've built, like I can actually test the Nginx like rewrite rules to make sure that they're pointing at the right part of our application. So I think that there's a real potential for testing in the ops side of things too.
Have you thought about using the framework for developers to instrument security relevant actions and events within the application, like input validation failures or failed logins and those kinds of things?
So the question is, do we do anything around instrumenting our application or having developers instrument the application for security failures and like login failures and things like that? And I have to say no, we don't do that, although I think that's an awesome idea. I mean, that's the kind of thing where you could set up a statsd kind of check or something like that and get notified if it spikes. Yeah. So the question is, who did these alert? And this is something that we're kind of working on. I was talking last night from Jason from VictorOps about, do we have developers on call? And right now we don't, but we're kind of trying to move towards that. So one of the things you can configure in our monitoring framework is like what service group this is for. So the one I'm talking about here is a dev service group, which means that it's like the responsibility of the dev team. So things that are infrastructure related, like MySQL going down, like that's an ops responsibility. They're the ones who would get alerted for that. And as far as like notifying how we do that right now, the developers are not getting paged with Nagios alerts, but we do post every alert and even like warnings into our HIP chat room. So people see them and are like, oh crap, I gotta go fix that.
Looking to see if we have any more questions. And it looks like we may be done. Oh no, we have one question right here. Okay.
So the question is like, where do I draw the line between like logging and like a Nagios check? I think for me, the tough thing about logging, and I mean, we do log everything, and we have Kibana set up to like let us go through those logs, and we use those. But like, you know, once you get at scale, it's like really hard to look at logs. You know, if we had cron email us when a job failed, we would have noticed the cron failure thing earlier, theoretically, but it probably would be emailing us all the time. So that's not really helpful. So I think you kind of need to use a combination. And we use some other tools, like we use Sentry for exception notifications. And you can also just instrument, you know, whatever you want to notify Sentry. And the Sentry like groups things together with common messages, so you don't get like this huge notification spam problem.
All right, if we can get a round of applause for Luke. Thank you, Luke. That was great.